Alright, example 2. A copper plate of thickness 1 centimeter is sealed to a steel plate of thickness 10 centimeter. So the temperature of the exposed surfaces of the copper and steel plates are 30 and 15 degrees Celsius respectively. So determine the temperature of the interface between the copper and the steel plates, meaning at this interface, berapa temperature there, and then the amount of heat flowing from the copper to the steel plate in 1 minute if the cross-sectional area for both plates is 50 centimeters square and no energy is lost to the surroundings. Okay, so let me just extract the information that we have. So the temperature for the copper end of the plate is 30 degrees Celsius, whereas the steel is 15 degrees Celsius. And then we have the distance, which is 0.1 meter, and then for the steel it is 1.1 meter. This now is 0.01 meter. And then the thermal conductivity is 385 watt per meter per Kelvin, and then the thermal conductivity for steel is 50.2 watt per meter per Kelvin. Alright, so when both rods are in steady state condition, we know that the rate of heat flow for the, this should be like this, for the copper will be equal to the rate of heat flow for the steel plate as well. Okay, so since we have that concept, we then can write this equation here. Negative K steel A Ts minus Tcs over Xs. Okay, so again, cancel out what you can cancel. You should then get the temperature at the interface of the copper and steel plate to be equal to 29.8 degrees Celsius. Okay, and then for question B, we have to calculate the amount of heat flowing in 1 minute. So we can then just use the amount of heat flowing between the copper and steel plate should be the same, so we can just use one of the what do we call it, one of these plate lah punya variables, I mean the unknowns, which is in this case we are gonna use the copper. So copper plate negative Kca Tcs minus Tc over Xc. So just substitute all the variables. In this case, the rate of time is in 1 minute, which is 60 seconds. 385 50 times 10 negative 4, 29.8 minus 30.01. So you should then get the rate of, the heat flow, the amount of heat flowing through the plate is equal to 2310 joules. Okay, so that is the solution for example number 2.